provider service. In a payment provider service, so what is the objective of today's presentation? The objective of this presentation is to showcase the architecture and design of Spring Boot based payment processing system that integrate with the Stripe payment service provider PSP. The system is designed to handle the client payment requests efficiently and delegate them to a Stripe infrastructure through a dedicated provider service. So today we will work on the provider service and return the process the response to the client. So this approach ensures the modularity, scalability and the maintainability, providing a robust and flexible solution for integrating the external payment providers within a service-oriented architecture. So as we discussed in the last video also, when if you observe in this diagram, when the e-commerce client send the request go to the validation service. So in our application we are means following the microservice architecture. In that we are having the three microservices: validation service, payment processing service and Stripe provider service. So when a client send the request, first the request goes to the validation service. After validating it, the request delegate the processing service. Then the processing service, it will save the whatever the client sent by the request, that data it will be stored into the database. So in last video we will discuss about this. So here the last video, in this we are discussing about the processing service. In that processing service we successfully store the data into the database by using the Spring JDBC named template. So now today we are what is the objective? We are working on the Stripe provider and it will talk to the external Stripe system. So in this flow, if you observe, when the client saying the request come to the payment processing service after the validation, then the payment processing service delegate request to the Stripe provider service and it interact with the Stripe PSP process system. Then same the response is sent back through the payment processing service to the client. So this is the entire flow of the our application. So now we will go through the coding. Open the Spring tool suite. So here, see, this is the project architecture. We are having the base package com.cpt.payments. In that base package, so we are return the main method. So after that, in a next package we are defining the constant package. In that constant package we are writing the app configuration related code, and after that the controller layer. So we are designing a layered application. The controller layer, we are writing a class, a payment controller. Then next we are defining the POJO package com.cpt.payments of POJO. In that we are writing the classes like a create payment request, create payment response and the line items. Next we are defining the DTO package. Here also the data is same, only we are defining as the create payment request DTO, create payment response DTO, line item DTO. Then the service layer. So this is the interfaces where. So one by one we will discuss about this entire project structure. So whenever client send the request in any application, okay, when a request come to the client, the server route that request to the servlet container. So now we will discuss about some basics of the Spring application. When the client send the request, the server route a request to the servlet container Again, it will route the request to the servlet class called the dispatcher servlet. So in a Spring Boot application, the dispatcher servlet will act as a front controller. So this dispatcher servlet is provided by a Spring framework itself. So it is not a class. So here we are not writing any business logic, only it is act as a front controller. So the dispatcher servlet dispatch the request to the application. Now when client send the request received by the dispatcher servlet, which is acting as a front controller in any application, through the dispatcher servlet the request come to the application, and who is receiving that request in application, that is a controller class. This controller class receive that request. To perform the business further business logic, then we need to to write that business logic, we need to of the service layer. So all the business logic we are writing in a service layer. So from this service layer we need to see, here we are defining, see this is the controller class, we receive the request from the dispatcher servlet, then from this controller layer it delegate the request to the service layer to further layer we need to delegate the request repository, and then this survey all the business logic after performing, then we need to delegate the request to the repository layer. From that repository layer we need to connect to the database. So yesterday we discussed how we are connecting to the database, how we are inserting the data into the database. So here in a transaction table we successfully inserted a data. In last video we already discussed, that is the continuation of this. Then we are focusing on today, the objective is that what is the today's objective, we are working on a Stripe payment provider survey. It will talk to the Stripe external system. Now, when the service layer, we need to delegate the request to the repository layer. From this repository layer, we need to connect to the database, that we understood. Then again, it sent back. So that repository, it will send back the response to the service layer, that database, whatever we are stored in MySQL database, it will send the response back to the service layer, and that service layer, see, it will send the response back to the service layer, and from that service layer it will the response is received by the controller, and controller to the dispatcher servlet, and from then dispatcher servlet the response goes back to the client. So this is the entire flow of the Spring Boot application. Now we will discuss one by one. First we will go through the main application, main method. So here if you are observing in this class, so this is the Stripe payment provider application. This is the main. Here we are writing a main method. So if you are observing here, we are using a annotation @configuration. So this configuration annotation indicates that the class contains one or more @bin methods and can be used by the Spring container as a source of a bin definition. So configuration, what is the main purpose? It is mostly the bin methods. Then next, Spring Boot application. So Spring Boot application, this annotation is the combination of a three annotation. See, Spring Boot application is the combination of a three annotations. Spring Boot configuration, auto enable auto configuration, and component scan. So one by one we will discuss. So what is the role of configuration? It indicates that the class has the bin definition methods, as we discussed. Itself here also it is having a, if you are observing configuration. So indicate that the class is having a bin definition method. The Spring container can process the class and generate a Spring beans to be used in the application context. Now, at the rate enable auto configuration. So if you are observing at the rate enable auto configuration. So at the rate enable auto configuration, it enables a Spring Boot's auto configuration features which attempts to automatically configure your Spring application based on the dependencies you have added. So where we are adding all the dependencies, we are adding the dependencies in a form.xml file. So here in a form.xml file, we are adding all the dependencies. Here. So what is the role of at the rate enable auto configuration? So it will configure the Spring applications based on the dependencies whatever we are added in this form.xml. So we are added the various dependencies in this. So we are adding the, see here, Lombok, JSON, model mapper, whatever the dependencies, these dependencies we are adding from the Maven repository. Or we may initialize to the Spring initializer. We may use Spring initializer to defining all these dependencies. Now the next, at the rate Spring Boot application, as we discussed, it is the combination of three annotation: at the rate configuration, at the rate enable auto configuration, just we discussed. It will auto configure all the dependencies, and the at the rate component scan. So at the rate component scan. So we will discuss about. So what is the role of this annotation? It tells Spring to search the components, whoever is annotated with at the rate component, create the bin objects for that, and means at the rate configuration, at the rate service, at the rate repository, all these are the stereotypes annotation. In your case, means our case, it scans the base package com.cpt.payments package and all related whatever the sub packages we are defining under this base package. So we are defining the base package constant, controller, POJOs, DTO, IMPL. It will scan all these subclasses and it will create the bin for whoever is annotated with at the rate component annotation. It will create the bin. Now next, at the rate enable async. This annotation enables a Spring asynchronous method execution capability. It allows you to run the methods asynchronously in a separate thread, which can be useful for a task that don't need to block the main thread, such as sending a notification or performing the background task. Then at the rate enable scheduling, this annotation enables a Spring scheduling support, allowing to create a scheduled task with the at the rate schedule annotation on the method. So we discussed what is the use of these annotations. Now next we will go through this class type payment provider application. So this is your main application class. So this class is the main application class. By convention, it's usually named as a application or a something similar. Now, next, public static void main string array of args. This is the main entry point of the Java application. The main method is where the application starts running. So Spring application dot run is called to bootstrap the Spring application. So here if you are observing Spring application dot run, this run method is called to bootstrap the Spring application, which sets up the Spring context and launches the application. So this run method, it will start our Spring application. So Spring application dot run Stripe payment provider application dot class. So here itself we are passing the class, it will identify this class name, and in this class, by using C spring dot application dot run here, so we are passing as a class. So this line prints a message to a console indicating, see here, system dot out done. This line prints a message to the console indicating that the application has started. This can be useful for debugging or confirming that the application was successfully launched. So what is the use of this main method? This main class setups the run the Spring Boot application, enabling asynchronous processing and scheduling the capabilities. It also configures the Spring to scan the components, whatever the components under the which within the base package, within what the base package is form.cpg.com, whatever the child classes, it will scan all those classes and it will create the bin for whatever the classes are annotated with the component, it will create the all bin. Now, then next we will discuss about the payment controller. First, see, after the main method, when the application will run, it will come to the controller. The request will come when the client send the request. That request is received by dispatcher servlet, who is acting front controller. From the dispatcher servlet in our application, the payment controller layer receive the request. That's why we will start with the controller layer. So here, if you are observing at the rate rest controller, rest controller annotation, this annotation is the combination here. Rest controller is the combination of controller and request body annotation. So it makes the class as a Spring MVC controller, model view controller, where every method returns a domain object instead of a view. The returned objects, whatever the returned objects, automatically converted to a JSON or a XML using HTTP message converters. So then request mapping. Request mapping v1 slash payment. This annotation maps the HTTP v1 slash payment method. So this is the base URL to the methods in this class. It defines the base URL for all the request mapping within the controller. Now then next we will discuss about the page. So here we are injected the two objects, the payment service object and the model mapper object. So @autowired private payment service. So the autowired is used for the dependency injection, as we discussed in last video also. Spring will inject an instance of this payment service into this field. This service is used to handle the payment related business. So this payment service, it will handle the payment related business logic. Now then, @autowired private model mapper. This model mapper is used to map between the different object models. Example, DTOs, POJOs, entities. Spring will inject all instances of model mapper into this field. Now next, so here if you are observing, so public response entity, like is create payment, @request body, create payment request. So we will discuss about. So this is the create payment method. Here we are using @post mapping, and the value is in a quotation is a blank and slash. This annotation, this @post mapping annotation maps the HTTP post request. The HTTP post request to v1 slash payment to this method, create payment method. It handles a request where the path is either, see, So we are given a value. Either it will accept the V1 slash payments or a V1 slash payments, means it will accept this URL also. V1 slash payments slash this. So public response, and next we will discuss about the public response entity, create payment response, create payment, @request body, create payment request, payment request. So this method handles the payment creation request. So create payment handles the payment creation request. It takes a create payment request object. See, it will takes the create payment request object. So the create payment request object we are defined in a Pojo class. This create payment request object. So this object itself, it is having the we will be in detail we will discuss this create payment request object. We are passing in this method from the request body. See, from the request body. So, and returns a response entity, create payment response. So it will accept the create payment request and it will send back the response entity. It will wrap in a response entity and it will give the payment response. This create payment response. It is having a ID and URL. So create payment request, it is having a private string, transaction reference, private list, line items, private string, successful URL and cancel URL. This request we are passing through this method and it will return the response entity. The response entity, it will wrap all the response in a response entity and it will give the create payment response, and this create payment response is having ID and URL. So @request body, create a payment request. See, this @request body, create payment request binds the, see, it will, this annotation binds the HTTP request body to the create payment request object. So see, what is the use of this @request body? @request body, it will binds the HTTP request body to the create payment request object. This object contains the payment details. This object contains the payment details sent by the client. So create payment request, which is having the client information. So client send the all this information. It will bind through this request body. Now then the system.out.println payment controller dot create payment. So this, it will print the incoming payment request to the console for debugging purpose. Now then next, here if you are observing, using the model mapper. So this model mapper is used to convert the create payment request. So this model mapper dot map payment request create payment request DTO. So the model mapper is to convert the create payment request object, that is a POJO object. So this create payment request is the POJO object to a create payment request DTO. So it will convert the POJO to DTO object. So DTOs are often used to represent the data transfer objects. The DTO objects are data transfer objects and can be tailored to a different needs or structures compared to a POJOs. Now then next, see all these after converting, then we will store into request DTO object. Now this system.out.println, it will represent print the converted DTO to the console for the debugging purpose. Now then this service.process payment. The service.process payment calls the process payment method of the payment service. See, this process payment we are defining in payment service IMPR. See, this process payment. So it will call this payment process to process the further payment. This method expects, see, this method expects the create payment request DTO returns a create payment response DTO. The create payment response, then finally see if you are observing. So we are calling the process payment. It will accept this request DTO and it will end the response. Then based on that, see again if you are observing by using the model mapper, then this service response we are again converting into a create payment response object. We are converting from, see here we are converting from POJO to DTO. Again here we are converting from DTO to POJO, and the final it will give the final response. So it will convert the create payment response DTO object back to create payment response object using the model mapper. So the model mapper, it will convert the POJO to DTO, then DTO to POJO here. So this object will use as the response to the client. So here if you are observing, so through this uh, means here if you are observing system.out.done, this we are writing for the debugging purpose whether it is properly converted or not. So it will then next the return new response entity. If you are observing the return new response entity, it will wrap the final response object. This response entity wrap the final response object in a response entity and sets the HTTP status created, means 201. This status indicates that the payment was successfully created. So this payment controller, it will handles the payment creation request. It handles the payment creation request. It receives a payment request. It receives the payment request. It will map into a DTO, processing it through a service layer, and maps the response back to the POJO and returns it to the client. It returns to the client with a 201 created status. So this model mapper for the object mapping, and this model mapper is used for the object mapping, and the payment service is used for the business logic. The response entity is used to customize the HTTP response. Now then next we will go through the POJO class. So here as we discussed the create payment request, in this create payment request we are defining the transaction reference. It is in a string. So the line items in a list, the success URL in a string, and the cancel URL in. So at the rate data annotation, actually here the Lombok is not working. So it automatically gives the setters and getters for this. So I manually define the setters and getters for this class here and to string method. If you use the Lombok and at the rate data, it automatically set the setters and getters and to string. Now this is the request body and this is the response. In a response, the ID and URL. Same here if you are observing in a this create payment response object, we are defining the ID in a string and URL also in a string. So this at the rate data is a Lombok annotation. It will generates the setters and getters and to string. Also it will set the equals method and hash code. And again if you are observing here, we are annotating at the rate builder. This is the Lombok annotation that provides a builder pattern implementation for this class. And at the rate all args constructor, Lombok annotation that generates a constructor with arguments for all the fields whatever we are defining here, and the iterate no args constructor Lombok annotation that generates a default no argument constructor. again I have defined manually the setters and getters to string. Also I have defined the builder class. So here public static class builder. So here I have manually defined. So public create payment response, it will build and return a new create payment response object. So this is the builder class. Next, the line items. So the line items here, if you are observing, private int quantity, private string currency, private string product name, private double unit amount. So here the quantity of the whatever the quantity of the product of the service one or two we are defining, the currency and the product name and the unit amount, whatever is defined by the client. So this is the line item. So you may use the Lombok also. So here again I am defining the setters and getters and toString for this. So this is the entire Pojo class. Next, this is the DTO class. So here the all the fields whatever defining in a Pojo, here the see if you are observing create payment request, only we are defining the in a DTO package, in a DTO class, create payment request DTO, create payment response DTO. So here the response also in ID URL. So here again I am using the builder pattern. So this is the line item DTO. Now then next we will go through the payment service IMP here. So as we discussed, what is the use of this DTO package? See, this DTO package, that is the data transfers for handling the payment requests and responses in our application. DTOs are used to transfer the data between the different layers. So we are defining the various layers of an application. Here, if you are observing, see, we are defining the controller layer, service layer. So the DTOs are useful in this transfer the data between the different layers. Now go to the service layer. So in this service method, see if you are observing this payment service here, at the rate service annotation, if you are observing at the rate service, and this annotation marks the class as a string service. All the business logic we are writing here at the rate service component. String will automatically detect it during the component scanning. See, as we discussed at the rate, the at the rate Spring Boot application is the combination of three annotations. So it will at the rate component scan annotation, by using this it will whoever is annotated with at the rate service, see at the rate service itself it is having the at the rate component, it will create the means you may use at the rate component, but for a service layer we are using at the rate service. All these are the stereotype annotation. Inside it, it is having the at the rate component, so it will create the bin for this check. So Spring will automatically detect it during the component scanning and register it as a bin in the application context. Services mostly typically contains the business logic and interact with the repository. Mostly it is used to interact with the repositories or other services. So next, so here if you are observing, the process, public class payment service IMPL. So it will implement the payment service. This line indicates that the payment service, the payment service IMPL implements the payment service interface. So, this is the payment service interface. Here we are defining the process payment. Uh, process it will accept the create payment request DTO as a parameter. So the request payment request. So the payment request we are defining here. So that parameter we are passing in this process payment, create payment request DTO, and see the DTO. Create payment request DTO. So it will accept this parameter. So the public create payment response DTO process payment create payment response DTO payment. So this process payment, so the method in the payment service interface, it processes a payment request and returns it will returns a create payment response DTO. So this process payment, it will accept the request DTO and it will return back the response DTO. So as we discussed, this is the request DTO. It will accept this request DTO and give response back as ID URL. So here it will means we are passing the request DTO and it will return back the response DTO. So this create payment request DTO payment request, this parameter represents the payment request data transfer object containing the details of the payment which is received from the client. Now, next, here if you are observing, create payment response DTO dot builder ID unique generated ID dot URL HTTP Stipe redirector URL dot bit. So now we are hard coded all these values. This code creates a new instance of create payment response DTO. So create payment response DTO, a new object ID represents the unique ID for the payment. So in actual real world scenario, this would be generated dynamically. Now we are hard coded. So URL, a placeholder URL we are defining, that http colon / stripe redirect url.com. It represents the redirect URL where the user would be sent after the payment process. Next, here if you are observing, so this line prints the response object. See here, if you are observing, this line prints the response object to the console. It is useful for the debugging of verifying the response returned by the service. So it will this line. See, if you, this line returns the created payment response DTO object as the result of the process payment method. So overall, the payment service IMPL class is a service component that handles the payment processing logic. In this example, the actual business logic is a placeholder um, simulating the generation of payment response with the fixed ID and URL. So the process payment method construct the create payment response DTO. See, this process payment method construct a create payment response DTO object using the builder pattern. So here we are using the builder pattern. Logs it for the debugging. So the logs are used for the debugging and returns it. This method would typically contain the logic which will interact with the payment gateway or other system in a real application. Now the payment service interface we are defining here. So here this payment service the public interface, the public interface payment service. This line declares as an interface named as a payment service, the name as a payment service, interacts in a Java, define a contract classes implementing the interface, the specify method that must be implemented by any concrete class. So we discuss overall whatever the code we are written here. So the main method we are using the various annotations. So this is the main point of our Spring Boot application. The Spring Boot, by using the run method, it will start the application. So we are using the app configuration we already discussed. Here we are using the model mapper. The model mapper, it will converts the POJOs into DTO and DTO into POJOs. Then we discuss about the controller layer. So the controller layer, it will the when client send the request through the dispatcher servlet, it will first come to the controller layer. From the controller layer, then it will delegate the request to the service layer. Then in a service layer, whatever the business logic, see whatever the business logic it will perform, and it will send to this. We will see here the payment service. Based on this, we are injected the service layer in a controller layer. Based on that, all the business logic whatever it will perform in a service IMPL class. Then here we are using that payment service, and then we are injecting here, and also we are using the model mapper. Based on that, all the business logic is confirmed. During this process, we are using the POJO classes and DTOs. Here, if you are observing, first we are converting the POJO into DTO, then the DTO into a POJO, and finally whatever the response is coming, we are wrapped in a response entity and we send back to the controller. So this is the entire flow of this application payment provider uh, service. It will talk to the, see as we discussed, it will talk to the external payment processing stack. So after processing payment processing service, after inserting into a database, again the validation service, it will send the request. That request will come to the Stripe provider, and we are writing the logic here. Then it will talk to the external Stripe payment, and it will send the redirect URL and ID, a unique generated ID sent by the Stripe provider service. That ID and URL, see as we return here the request, if you observing respond to ID and URL, it will send a unique generated ID and URL sent by a Stripe, that will send to the again back to the Stripe provider to processing to the validation to the e-commerce client, and the e-commerce and redirect on that URL. It will complete that processing payment, and then the status was created. It will be the payment is initiated, created, failed, or a success. It will use through the webhook, the Stripe provider service. It will send that webhook also. We need to send from Stripe to Stripe provider processing service, and from validation to the e-commerce client. So this is the entire flow. Now then we will go through the post. First we will run the application. We will run the application here. Run as a Spring Boot application. This processing. So there is no compilation error. The service is started on a port number 8086. Now then we go to the postman. So here first go to the controller class, check whether we are writing the correct URL or not. So this is the base URL /v1 /payments, and our port number, see the application is running on 8086. So http colon double slash localhost colon, so the port number 8086 /v1 /payments. So here we are defining post mapping. So we may use a v1 /payment, or we may use v1 /payment or slash. So now we will go through this URL. So the request body. So we will study the JSON format we are sending. Go to the application, check whether all the response. See if you are observing here, request body. So transaction reference. So here we are writing transaction reference. Then the line items. So line items. So here quantity is to currency, product name, unit amount. Check whether we are defining it correct or not. So the line items, the quantity, currency, product name, unit amount. So here we are passing two line item objects, and again the success URL and cancel URL. Check here we are defining in a payment request. See here private string transaction reference, line item, success URL and cancel URL. So everything is correct. Here we are defining transaction reference, the line items. In that line items, everything is okay, quantity, currency, product name and unit amount. Then success URL and cancel URL. Then send the request. So here we are getting the response. The ID is unique generated ID and the URL is, so whatever. So now we are hard coded that value we are getting back. So if you go through here in a service IMPL, so unique generated ID and the Stripe redirect URL.com. So that response we are getting here. See here. So everything, the application is working whatever as per whatever we are coding. So here now then we will study the log. So in a payment controller, see if you go to the payment controller. So the create payment. So here it will print the payment request. So transaction reference, the line items. See here if you are observing transaction reference, the line items, whatever we are passing to line items, quantity here 2 and the quantity is 1. The currency, product name, unit amount, everything it is coming here, and the success URL and the cancel URL. Then here if you are observing, we are converted the POJO into a DTO. So here it is successfully converted POJO to DTO. So here if you are observing, all this data is converted from POJO to DTO. Then the response object create payment response DTO. So here we are getting ID, unique generated ID and URL, and converted again this response back to a POJO. From DTO to POJO we are converted, and final response we are getting. See here, final response ID is unique generated ID and the URL is http://stripe redirect URL.com. So everything is working as per we are coded. We studied also log. So this is the entire flow of the Stripe payment provider service.